Okay, I think let's head into some timelines, and I think timelines are where it's at, and they're so good. So come on, go timelines, yeah. Okay, no, so in all seriousness, here we're heading into timelines, and what timelines are useful for, kind of a more real life scenario where you might invest a little bit of money in, then a couple of years later you put a bit more money in, and then a few years later you take out some money. This is real life. You don't, put some money and then forget about it. Of course, withdrawing and adding in that. So let me get into my box and go for it. So here's our first example. I'm going to cover all this idea of T0 and Tn and all of that in our example. So withdrawals and deposits. For today, you're just withdrawing and depositing, and tomorrow or the next one, whenever that will be, the interest rate might change because it's never fixed forever. So we're told, let's listen through to our story. What do you reckon? Should we listen through? So we got 8,000 Rand is deposited into a savings account, and okay. 8,000 is deposited into a savings account, and 2 years later, a further 14,500 Rand is deposited. 5 years after the account is opened, 6,000 Rand is withdrawn. Calculate the accumulated amount in the account at the end of 6 years of interest is 7.5. So let's just, make sense of what's going on here. We're putting 8,000 Rand into our account, but then 2 years later, we're going to put a further 14,500 Rand. And 5 years after the account is opened, we're going to take out 6,000 Rand. Now, we need to see what's going to happen after 6 years, at the end of 6 years. And our interest rate is going to stay the same at 7.5% per annum. So to do this, let's create a timeline. So over here, we're going to say T0 is where we're starting. Kind of now, 0. And then as we go along, or we could do this, come on. So up here, we start at T0, and then kind of as we go along, things are going to happen. And then by the end, it'll be end of 6 years. So at the end, let's put T6 over here. That's when we withdraw our money. And let's draw a lovely straight line across there. So this is broken down into there's 3. So we've got 1, 2, 3, 4, 5. But we're not going to use, we don't have to show every single year because it's not like something exciting happens every year. So 8,000 Rand is put in. So if we put 8,000 above T0, we're saying we're putting 8,000 Rand in. 2 years later, a further 14.5 is put in. So at T2, so we didn't actually have to show this part here. But if you did have that, that's fine. I like to have a bit of a scale to my timeline, but you don't need it. It doesn't have to be a perfect scale. So we're going to put in 14,500 Rand. How about you? Could you do with 14,500 Rand being put into your bank account now? If you answered no, then yeah. So, maybe we could get a heater in this cold and, get some books for our mansion. So then what we're going to do is 5 years after the account is opened, so 2, 3, 4, at T5, 6,000 Rand is withdrawn. So we're going to take 6,000. Now, there are two different ways we sometimes show this. Either you can put a minus 6,000, or sometimes people put 6,000 in brackets somewhere, or you maybe combine that. Minus. The point is we want to somehow show that we're withdrawing 6,000 Rand. So there's our 6,000. Yeah? Oh, sorry. I thought somebody was just calling me. So we're taking 6,000 Rand out. Okay, so we've represented that over here. And then at the end of T6, our question is, over here, how much money do we have? Our interest rate for the whole time. Now, it stays the same, but let's just get used to doing this because often our interest rates are going to change. So let's do that and say that our interest rate is 7.5%. So 0, we did this in first. So let's get back to those questions. How could we represent 7.5% as a decimal? Well, it's 0.075, right? And it's compounded monthly. So I like to just put a 12th in there instead of writing monthly. But if you write monthly, that's fine. So that's our interest rate for the whole time. So now all the information in that paragraph up there is represented in our timeline. Now, here's the magic. So I can withdraw. I can move down here, okay, and let's put all of this into some sort of formula. So the amount of money we're going to have that's going to accrue. Well, that 8,000 Rand, let's say that we invested that 8,000 Rand for the whole time, right? 1 plus 0,075 over 12. Now, if it's 6 years and it's compounded monthly, how many compounding periods are there? Well, I think we got 6 times 12, which is 72. Now, I think it's useful to just write 72, not 6 times 12, because, we're going to keep our thing. So that's what would happen with the 8,000 Rand if it were left in the account the whole time. What would happen with that 14,500 Rand? Well, if we invested that 14,500 Rand, it's being invested 1 plus 0,075 over 12, but it's only going from T2 to T6. So how many compounding periods is that invested for? Well, 2 to 6 is 4. 4 times 12 is 48. And it may feel a bit weird, you think, but wait a second, what about this 6,000? Now, it kind of just works out nicely that if we take our 6,000, we say we subtract 6,000 Rand, but we're not just subtracting 6,000, we're subtracting whatever interest it would have earned for that year. So if we subtract 6,000 for that year, those 12 months, then this formula, this equation at least, formula equation, I don't know. What's the difference between a formula and an equation? Oh, that's going to be an interesting one to see. I don't know. Well, let's see what you have to say. So I'm going to just move out the ways here so you can see that equation for a little bit. Or formula, I don't know. Whatever, that little working out thing we've got. And I'm waving my hands. Wouldn't it be cool if you could see my waving hands? Maybe not. So we've got our 8,000 Rand that we've invested for the whole time, plus the 14,500 Rand with whatever interest it's earned, minus the 6,000 Rand and whatever interest it would have earned. We're not going to get that as well. So there's our magic formula or equation or something or other working out. And we can go cool equals, and that we just need to punch into our magical genie. And where's my magical genie? Oh, there it is. It just appeared. Wait. Otherwise, the magical genie is unhappy. So there's our magical genie in the way. And let's see. I can move my magical genie around. I guess I can do that. So you can work that out. I'm going to say work it out. And then when you get back, I'm going to have worked it out because I'm going to disappear and be back with the answer just like that. Now, question for you. So let's just move our calculator. It prefers to be up in the corner there. There we go, calculate. You can be back to where you want it. So we get our answer of 25,617,83. Now, question for you. Did you... That's weird. Go away, calculator. Did you get tired of writing this thing in again and again and again? Well, only 2 agains. Did you get tired of rewriting that in the calculator a few times? Okay, maybe you didn't. Well done, you've got stamina. But, when we've got it in our calculation, I felt like I typed it in, and then I made a mistake and I had to delete. So here's a nice calculator trick for you. Let's actually go into the calculator like that. Now you can see it a bit better. So I go press anyway. So that part of our equation was 1 plus 0,075 over 12. And we kept typing that in again and again. So if we type that in and press equals, now it's sitting on our calculator, whatever that number is. And if we store it in A, so if you can see, I don't know if I can get quite across that far, I can't, that we want to store that in the first variable A. Now store is in yellow, so it relates to the shift. So we have to go shift store. We're busy waiting to store. Where do we want to store it? We want to store it in A. So we press A. Now that answer's an A. So if we go alpha A, because it's red, that's going to be that number. So now when we went to our formula, we can go 8,000 and just go, well, that was A to the power of 72. So let's head back there to see how that matches up. So that 8,000 that we got times, instead of typing in that, we can just go, well, that's A to the 72 plus, well, plus over here at least, plus 14,500. And instead of writing that whole bracket, we know that that whole bracket's A, and it's A to the power of 48 minus 6, 1, 2, 3. And now we can go alpha A to the power of, whoopsie, that wasn't, I don't know, no, go away, go. Well, if you knew how to use a calculator, let me know. Alpha A to the power of 12. So, whoopsie. Now it looks like I made a mistake. Oh, this is quite, see, now instead of going, I can see where it is, it's over there, wasn't it? Oh, sheesh, I'm not selling this alpha A thing, am I? So, there we go. Oh, I made a mistake. It was a little bit easier to find, actually. 1, 2, 3. There we go. That seems a bit better. So, and maybe that is a good advert for this, using the variables. Because, it's easier to spot. 8,000 times that bracket to the 72, 14,500, 6,000. It didn't actually take me too long to spot a genuine mistake I made. So, don't worry about practicing that in this one. You're going to have more than enough time. We'll practice that in the next one. So, goodbye, calculator. But that's storing in variables. So maybe let's just capture this as a note that you're going to go shift store, and then wherever you want to store it, say an A, and when you want to get that back, you're going to use alpha A to get it back. So pause just so you got that there. Excellent. So let's do our second and final example for today. Okay, so here we got a savings account is opened.
Bruh.
Who keeps calling me? Anyway, a savings account is opened with a deposit of 25,000 Rand. So, I don't know, may or may not be useful, we talked about colors in that before. Sometimes colors are useful. And then we say 18 months later, 16,800 is withdrawn. So maybe I want to kind of put my brackets around, I'm ready to withdraw that. 3 years after the account is open, a second deposit is put in. So we put in that as a deposit. Calculate the accumulated amount at the end of 4 years. 4 years is probably interesting information. 4 years. If the interest is, running out of colors here, 8.4% compounded quarterly. Now we're going to have to re-look at our paragraph, but let's get our timeline ready. So I'm going to, again, because this is just the second example, I'm going to get you ready with T0. And at the end of, what should this be? T what? I reckon it's T4 because it said 4 years. So in my head, I kind of just ready to do the things like T1, 2, 3, 4. Okay. We put in 25,000 Rand. Easy enough. 25, easy enough to put into it. Easy enough to show on our timeline. 18 months later, 16,800 Rand is withdrawn. So now, if it's 18 months, that's going to be T what? Now it's going to be, and this is going to be interesting, that it's kind of like T1.5, because it's not T18. These are always going to be years, because the interest could change. It could be quarterly, monthly. So it's kind of a T1.5 is when we're going to withdraw our 16,800 between T1 and T2. 3 years after the account was open, a second deposit is put in. So 3 years afterwards, so T3, I'm not going to ask you that one. And we're going to put in 32,600. And our question is, at the end of all of this, how much money do we have? And although the interest rate stays the same, we're going to capture that in our calculator, in our timeline, and go, interest rate is 8.4%, 0,084. Let's make that comma clear. And that is compounded quarterly. So there's our timeline with all our information. This really does give me a good sense, and hopefully just gives you a chance to pause as well to try and put down the equation now. Use your first one for reference. Write down, did you manage to put down some idea for an equation? Not suggesting that you're going to know 100% how to do this, but just some idea of how to do this. No, we've heard that one, right? Okay, so let's see. Pop it down and jot down your reflections on how you're feeling. Okay, so I'm going to do it here and say, let's see, how much does this all accumulate to? A equals, try and give myself a bit of space because these equations or this working out becomes quite long. So, it might end up being over 2 lines, but that's not ideal. So we're going to put in our 25,000. I just have to keep an eye on how many zeros. It's these huge amounts of money. And we've got 1 plus 0,084 over 4. And we've got 4 years times 4 gives us 16 compounding periods, because they're kind of 4 in each of these. Imagine 1, 2, 3, 4. Each of these is a quarter. So therefore, if we kept doing that, we'd have another 4 quarters, another 4, another 4. We'd have 16 quarters altogether. So hence 16. Okay, then we withdrew this amount. So we want to subtract that along with any interest it would have earned. 1 plus 0,084 over 4. Okay, but now this is from 1.5 to 4. So how many compounding periods is that? And this would be as or more interesting. How many compounding periods and how do you work that out? Okay, well, I might just think, well, from 1.5 to 4, that's what? 2.5 years. So 2.5 times 4 gives me 10, I think. But another way to think about it, so that's definitely a useful quick way, is to go, well, we've got 2 quarters in here, right? So that's a half. Or it's 2 quarters, I should say. And then we've got 4 quarters in here, quarter, 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 quarter. And in this last year, we've also got 4 quarters. So maybe if we count those up, we've got a group of 4, and just 2 over here. So 4, 8, 10. But I think the easiest way to think about it is this over here is 2.5 years. So 2.5 times 4 gives us our 10 compounding periods. Maybe I'm overthinking that, but maybe or maybe not useful. Okay, now that I've scribbled all over here, I really want to show that is T3 for that one. And we're going to also get interest on our 32,600. Was it that much, 32,600? Yeah, just checking. And 1 plus 0,084 over 4. And this is just for 1 year, which is 4 quarters. For this one, most definitely, I'm in the way, that part there. Okay, so definitely practice using that shift store in your calculator. So I'm going to run through it with you again and say we've got 1 plus 0,084 over 12 equals shift store in A. That means that, is that right? So let's just run through that again. 1 plus 0,084 over 12 equals shift store A. That means that amount there is in A. So now when we do our formula, 25, 1, 2, 3, alpha A to the power of 16 already feels a little bit better and more manageable, minus 16. I'm just going to run us through this one. How about that? Alpha A to the power of, I need to move this out the way for myself, 10, right, plus 32,600 alpha A to the power of, let's just have a look there, what is it? That guy in the corner is in the way. To the power of 4. You can come back to the power of 4 equals 43,460. Okay, 43. I don't know. Is that what you got? I've done this previously. I don't know what I got. So let's open with that. Quarterly. I didn't write down my answer previously. Hopefully that's the right answer. That's what I get at least. And yeah, that is that. Sorry, I was just like, I always feel worried in finance maths that I've just put a wrong number somewhere. It just feels so easy to do. 60. that somewhere in this calculator I put an extra zero or something like that. Just feels too easy to do. So, maybe just as your parting shot, just shout, is that the answer you got? Did you spot any mistakes? Does that seem okay? And are you ready to finish this all off?
Well, if that's the case, then
Make it math.